All right, we are in the setup panel still. I split this into another video because it was getting a little bit long. To get that tiny little micro scale domain to show up, I hit the fit button up here, and that's when we start seeing the vectors. And you also have some other buttons like you can zoom to area. We can try that. Oops. Zooming in and zooming out, and we're starting to see the velocity vectors. So this inner wall has the 0.1 or 0.1 1 millimeter per second velocity, and then you have to have, because we don't have any outlet or inlet, everything's got a dead end and turn around, pressure builds up, which we'll look at in a minute, and stuff flows back along the axis. And one thing you might start thinking is, well, there's a lot more stuff coming back up the axis than it appears on the side. So here's where the cylindrical symmetry, pays off, is that there's a lot of wall around the outside. So continuity is probably not being violated. But one thing that would be really good at this point, and what a lot of people do, is find a solution that they know has an analytical or well-known experimental solution and compare it to that. And for my example, it might be a long cylinder that's just got a moving wall like an electrokinetic pump. So that's something on the to-do list, compare it to a known solution. But back to pressure, well, contours is another way of looking at things that are scalar, things that don't have a direction. So we can go in there and set that up. Contours of pressure, and it's such a common thing to want to know that it comes in as the default. And we can do display. And we get something nice and symmetric. And you can fool around with this stuff. You can flip and show the other half of this. So we're doing a cross section across the whole pore. See if I can do that. One thing I like to do is have a field contour. And it's a little bit chunky, so we can add more levels so it looks a little more continuous. Display. Okay, and then close that, and let's fit that in the window. And what you see is that this pore, by doing this pumping in this direction, is causing a pressure gradient. Most of the pressure drop is in the pore, as you might expect, and then in these large areas you have the constant pressure, low and high, and you can actually read it off the scale bar right here. I don't know why I've got this black line today, but that's weird. But what we might want to do is analyze that. This is the maximum pressure that such a pump can attain. It's got a closed end, a dead end, and that's how you get your Pmax. Qmax, maximum flow rate, it's got no flow rate right now. The net flow is 0. You got some flow this way, and then it's coming back. It's got to do that U-turn. So what we want to do in a later simulation is open this up and have 0 pressure drop across it. That's when we're going to get our maximum flow. Okay, what else can we do here? I'll go to do one more thing, which is in here. We can mirror it on the axis, and then you start seeing the other side of it. And really remember, we're flipping this thing all around the axis. And there's some really nice options. If we save this and we go back to Workbench, save project, close it, close Fluent, but still have Workbench open, and there's a results panel, and there's some really amazing options, but you can get very far with just solutions. So I'm going to stop there.